folks, this is the next video for further maths GCSE, and we're looking at the equation of a circle. Now there is an overlap here with GCSE maths, and we'll talk about that as we go. So if I draw a pair of axes, I might even have a pair of compasses here. Bit exciting. I have got a pair of compasses. Might as well make my circle circular. Oh, I'll move that out of the way. My compasses aren't very good, and so I had to draw my circle manually. However, it's a circle. If we take a random point, that could be any point on the circle, so I'm just going to label it X, Y. My radius could also be anything, so I'm just going to label the radius as R. I'll drop this down. I've got a right-angled triangle which has a width of X and a height of Y. So by Pythagoras, x squared plus y squared equals r squared. And that's it really at GCSE. Any circle that's centred on 0, 0, and this is the key, it's centred on 0, 0, with a radius of r, that's the equation it has. And that's it. That's all you need to remember. Because if you think about it, even if x is negative, well, minus x squares to give x squared. If y is negative, minus y squares to give y squared. So it doesn't matter whether x and y are positive or negative. All the points on the circle fit this equation. So that is a GCSE circle in that it's centred on 0, 0. Okay, pause the video. Write down the equations of these circles. That's got a radius of 1, that's got a radius of 4, that's got a radius of 10, and draw the missing circles, please. Okay, here come the answers. They're all centred on 0, 0, and they all have a radius of the square root of that number there. Okay, there you go. GCSE circles done. Now further maths circles are not centred at 0, 0. So what happens if I move my circle so now it's centred at AB? Well, I'll show you on my high-tech diagram. There's the axes. Circle then. There it is, a beautiful circle, and it's centred at AB. I'm still going to take the arbitrary point or the general point XY. I'm still going to call the radius R. And I'm still going to consider the right-angled triangle that I get when I drop the vertical from X and the vertical from the centre and the horizontal from Y and the horizontal from B. So we know on the Y-axis that's Y, that's B. We know on the X-axis this is A, this is X. So we can say that the length or the width of the triangle is X minus A, and the height of the triangle is Y minus B. So again, by Pythagoras, square the two short sides, and they equal R squared. So this equation defines a circle that has a centre A, B, note the sign change, and it has a radius of R, or as pirates say, R. I know, but you know, that's why we're here. Okay, probably worth making a note of that, I'd say. And then pause the video again. Fill in these, please. Okay, here come your answers. It's a GCSE one because it's centred at 0, 0. Note the sign change, -1 and -2 from 1, 2. Now, you'd be expected to square 2√2 without a calculator. Okay, if you need to, pause, get your head around those. Have a go at some of these questions. Pause it, and then I'll show you the answers. Okay, so I know the centre, I know the radius, so straight away I can write down the equation of the circle. I want to know when y equals 0 to give me my x-intercepts. So I set y to 0 in my equation. When I do that, clearly the bracket 0 minus 4 is just -4, and that squares to 60. So I set y to 0 in the equation, take 16 from both sides, not forgetting that there are two square roots to 9, and that's why I've got 2 points of intersection. So I'm just solving this quadratic, and I get 2 values of x. So I can see that the x-intercepts are at 0 and 6, so obviously this one is a 6, 0. My technique is the same to find b. I recognise that this is on the y-axis when x equals 0, so in my equation I set x to 0 and solve the resulting quadratic. Again, if you need to, pause, get your head around this. Here come some questions. Pause it. When you come back, I'll talk you through the answers. Okay, so for the first question, I write out the equation. I set my y to 13, solve the corresponding quadratic. The second question is sort of backwards. If I set x to 2 and y to 5, let's see what happens. Well, I end up with 20. Well, 20 is not equal to 16. So this 0.25, these are not a pair of values that satisfy the equation for the circle. So no, this point is not on the circle. Okay, this is an actual past paper question. There isn't a diagram, but you know what that looks like. It's a circle with a centre of 7, 4 and a radius of 9. The line y equals 6 is a horizontal line. So here's a diagram. There's a circle, there's a horizontal line. I need to find these 2 points. So I do that by subbing in, what do I sub in? Yeah, I sub in y equals 6, 6 minus 4 is 2, 2 squared is 4. So I find the 2x coordinates, and since they are on the same horizontal line, the distance AB is just the difference in x coordinates. There are some questions for you here. I'm going to put a worksheet into the file section. You don't need to work off the screen. I'll give you the answers. So exercise 1 on the worksheet. There you go.